need to ask questions, at the end of the session, all you have to do is click on where it says raise hand, and in the questions box, write down your question. When you finish writing down the question, just click on the send button beneath, and at the end I'll go through all the questions and try to answer them to the best of my abilities. Again, all you have to do is click on raise hand, write your question down in the question area. When you finish writing down the question, just click on the send button as shown over here, and then I'll answer it at the very end. Okay, as I said, we'll be talking about different ways to actually work with HSS. Now, we'll start off with this with an easy situation, and the part that we see on the screen, as shown over here. What I'd like to do is to machine out these surfaces over here. Okay, so I started a simple operation over here. I just opened it up and show you exactly what I did over here. I used simple parallel cuts, constant Z. My geometry, as I said, was these two surfaces that I want to machine. The tool will be a 6mm ball end mill. Tool path parameters every 1/2 millimeter. Let's do a quick simulation. And as we can see with the tool path that's formed over there, that the tool goes back and forth and machines it apart exactly the way I want it. Fine, no problem. Now what I'd like to do, however, is machine not only these two surfaces as shown over here, but I'd like to machine as well the surfaces on the other side. And I want to do that in the same operation. So, rightfully thinking so, I would go to geometry and go to edit and just add those surfaces on over there, that one there as well. Just click on OK to accept, run my simulation, and we see that it machines both sides. However, note, now that we have a gap between this surface and this surface, it starts acting the way gaps act. If there's a large gap, in this particular case, it went up all the time. So what we would like to do in this case is go into our links and into our large gaps. Now, the way I'd like to work in this particular case is that when I finish this one surface over here, I like to just like blend myself into the other side. I'll just leave this with sort of an arc and then come back on the other side, blending its way into the surface itself. The way I would do that is simply go into large gaps, and instead of clearance area, I'll use the option of blend spline, where it blends one surface together with the other surface. Let's take a look at how this looks now once I created this particular gap. And as you can see, it works smoothly from one to the other, finishing off this side, moving smoothly onto the other side as well. Hold on a moment, please. Okay. Okay, sorry I had a little technical difficulty for a second. Let's get back to what I was doing over here. And as I said, as you can see over here, we have the exact arcs exactly the way I want to actually work on it. That was done simply by going into the operation, and in the links field, where I had links, gaps along cut, the large gaps I told to blend the spline together. Okay, let's take out another part now instead of this part. A little different. Okay, we have a part that looks like this. Take a top view of it. And what I'd like to do in this particular case is mill out this surface over here. Now, it looks like a pretty simple task to do. However, it should note that this surface is actually an undercut underneath this top surface over here. It actually goes underneath it. So the way to do that, again, the only way to do it is using HSS. Now, the type of tool obviously has to be the correct tool type. And in this particular case, the only way to get in there properly is using what we call a Lollipop tool. Okay, now, let me just open up the operation. And as you can see, I'm using the option of morph between two boundary curves, where my geometry, let's take a look at it from the top view. My drive surface, and I'll zoom in, are these surfaces over here, as well as this little thing over here. That's also part of the surface I want to machine, and that's all undercut. You can also see that pretty much so from these lines over here. That's part of the geometry. And if I look at my start edge, you can see going along that edge over there, and my end edge over there as well. Taking a look at the tool, in this particular case, I have a Lollipop tool as shown over here. I have my toolpath parameters. I'm doing actually a pretty fine cut of 0.1 millimeters as far as the surface. I want to have a really nice smooth surface finish over there. And let's go into gauge check, and I'll talk about gauge check in a moment. Running my simulation, you can see that my tool goes down. You can actually see the tool path, how it curves underneath. However, there's something we still have to look out for. We still have to look out for this surface, because the tool's going to come down, and if I do this in Solid Verify, the tool is going to come down, and you can see that's actually touching this surface as it goes down towards where it has to machine. So I actually want to do a gauge check so that it doesn't touch that surface. So over there, in this particular case, I'll go into gauge check. I'll enable my gauge check, and I have my check surface, I did a little research before, as that surface over there. And I'm telling it also stay 0.1 millimeters away from that surface. Now if I run my simulation, obviously it's doing a calculation first, and I'll run Solid Verify. You see it goes down. This time it does not work on that surface over there, just underneath as shown. Now let me stop over here. Let me do this again in HostCAD. If we take a look at the part, I've machined this surface as I've shown over here. However, what I'd also like to do is not only that surface, I like to work on these surfaces here as well. Now in this particular case, these surfaces are divided exactly equally around the center of the part itself over here. Now, I can go into SolidCAM and use the regular transform operation. However, inside HSS, we have a transformation option inside the operation itself, where I can say, let's do rotate or translate. I'll activate the use rotation translate, and I'll use the option of, first of all, how many steps do I need? I need to do 10, including my original one. I have my rotate angle starting at 0 and rotating every 36 degrees. 360 is a full circle, divided by 10 gives us 36. Let's just do a quick calculation and simulation of the part. And as you see now, it's working on the first one, the second one. It's working on all of the surfaces as shown over here. Just do a quick, simple rotation, and that's done within the operation itself. Okay, By the way, a quick reminder, the webinars are being recorded, and if we were to go into our SolidCAM site, you can see we have in the area of webinars, we have webinar recordings. By going to webinar recordings, we have a list. You can see all the webinars that were done so far in this series, and tomorrow at around this time, the this webinar will also be posted there as well. So if you missed something that I've mentioned now, you can always go back and see it again. Okay, let's continue now with the HSS. I'm going to close this part. I'll load my next part. Now we're getting into a little more of a difficult situation. If we take a look at this part, I actually remember helping the customer out with this part. It actually worked out very well at the very end. This actually looks like a very simple part. Okay, what we see here is a block, a little flat surface over here, drill a hole over there as well. What we don't see is what's on the inside. On the inside, you can see we have this surface over here. Now, this surface is obviously an undercut, and it has to be machined. Now, since we're working in a 3-axis machine, the only way I can get into it is going in through this hole. But I have to also have the proper tool. Now, let's do a little further investigation of the part itself. The hole over here is a 8.5 millimeter hole. And in other words, I have to have a tool that's smaller than this, but that later on can reach out to go into this area up to this point over here. In other words, I need a T-slot cutter. Now, the T-slot cutter, however, that I need is a special type of cutter. This is not your standard T-slot, because in order to get to this area over here, the actual arbor of the tool has to be pretty thin. And then we run into a problem of, if I'm cutting very thin, it's a very thin arbor, once I start moving in a circular motion on that surface over there, I'm going to break the tool because there's too much pressure on the tool. So the way we did this was actually, and it actually worked out pretty well, was we used the option of perpendicular to curve. Whereas in my geometry, the face that I had to machine was this face, as shown over here. The lead curve itself was this curve over here. Now, the way the tool is going to work, because I told it to work perpendicular to this curve, it's actually going to work back and forth, up and down on this surface. So the pressure on the tool actually ended up being up and down on the tool instead of to the side, where it, obviously we had to work pretty slow, but this was able to be done, and it actually worked without any problem. Now, there are other things we also had to look out for over here. Let's go through the operation and we'll see exactly what was done. As I said, we saw our geometries. My tool in this particular case was a slot mill, as shown over here. The diameter of the tool was 7 millimeters with a 1 millimeter radius on the corner. The cutting length was a total of 2 millimeters. So in other words, you actually had a full radius on the tool itself, on the cutting edge itself, the full radius. Now the arbor itself was only 2 diameters. So we had to work slow, we had to work up and down. We could not work going from side to side because that would put too much pressure on the tool. Okay. We have our, we have our tool path parameters. And now we have our gouge check. What do we do in our gouge check? Well, if I go into my gouge check, my second gouge check over here, we have check surfaces. What did I pick as my check surfaces? My check surfaces, as shown over here, is this surface over here. Basically, almost every surface around this area. This surface over here, this one over here, this inside hole over here, and the bottom over here as well. And these are the areas where I do not want the tool to touch. Fair enough. Because I have to actually force the tool somehow to go through the middle of that hole, into that hole itself. And the only way to do it is by telling it, okay, you can't touch any of these areas. So the only way it can get into that area is going through this area over here. Now, okay, one moment please again. Okay, sorry for that interruption. Okay, now, we have our gouge check, and all I did was tell it to do retract along the tool axis. So it'll actually just go according to the z-axis, going up through the part itself. Let's take a look exactly what happened, and I'll do this one step at a time so you can actually see it. You can see the tool goes down into the hole, and now let me just flip it around to the side over here. We take a look underneath. You'll see that the tool, let me do it again slowly so you can see a little better. It goes down, back and forth, up and down on the surface itself. And you'll note, I'll zoom out now, when it finishes, it goes back exactly the way it went in, without gouging the part itself. This actually worked very well for the customer, and that's the way we decided to do it, and we kept on doing it this way, and it worked out to be one of the best ways to do it. Okay, now let's take one more part, and the part I'm going to use this time looks something like this. Well, not something like this, it looks exactly like this. What do we actually have on this part? On this part, we have all these nice little surfaces over here that have to be machined out. No problem, it can even be done with a regular profile or HSM operations. We even have some of these surfaces, but we also have these surfaces to be machined out over here. And we have this area over here, which is actually undercut from that surface on top over there. Looking from the top view, you can see that this area over here is covering over that surface over there, as well as this surface over here, these areas over here. So the only way to do this is again using HSS. Now I programmed this entire part, and I actually want to go through exactly what I did on the entire part itself before I got to the HSS. Because in this particular case, we use the HSS to finish off the areas that could not be machined in the other ways. So at first I started with my operations, and just to clear out my bulk of the material, we used 3D iMachining. iMachining 3D to machine out these areas over here. If I were to take a look at the operations that I used, I just go through it one at a time. Simulate. My first operation, let's use a solid verify over here, did iMachining around the part over there. And as you can see, with the iMachining, it did a simple but very effective morphing spiral cut around the outside. Right now it looks like a regular spiral, but you can see later on as it gets towards the middle over here, it'll actually finish off with a rectangle shape. So it's actually morphing itself to get to that shape over there. Let's go a little quicker. And as you can see, it's moving in using the iMachining 3D to machine out the part. Now, now we're taking a look at how we would actually machine a complete part and and then at the end we'll show how HSS helped us actually make that part come to life. Okay, we had this first area over here. The next area, I just finished off this floor over there. Then I continued on working these areas over here. Let me get rid of the tool paths. Machining out these areas using iMachining, the 3D iMachining, where it goes down, every single layer that it has to go down to, as shown over here. Then it comes back up when it finishes these areas. It'll come back up in a moment, okay? And machine out on the step ups now. It'll start working on these areas as shown over here, working on these steps on that angled area, doing all the rough cuts in that area. I just do it on this one side and then I'll stop it. Cleaning off this area, and then I'll do the exact same thing in these areas as well. Again, clearing out this area and going up with the steps. It'll do the same thing on that side as well. All right, I'm going to stop it over here. Then we'll go to my next operation. Now, my next operation, I decided, you know what? This is up until this point, from this area up until this area over here, is just a simple T-slot operation. So I have my T-slot operation over here, where my geometry was that simple profile on the inside of that undercut over there. My tool was your standard T-slot cutter, as shown over here, your slot mill cutter. And let me just do a quick run on the simulation itself. You can see that the tool goes down, works its way around, machining out that area. Okay, so right now, all we did was 3D iMachining and a pocket to clear off this floor over here. And we also did a T-slot cutter to cut away this area. Now I decided to do that now. This way, clearing this area over here so that my Lollipop tool, which I have to use later on, won't be bothered by any of this kind of material that's over there. Okay, clear that area out. Now I did a finished cut before dealing with this area using HSM. By the way, the issue of HSM will be a different webinar altogether, so I'm just going to go through this quickly. I just used the option of constant Z in HSM, using a typical 12mm end mill, and my constraint boundaries was a working area over here, working inside this area over here. Obviously, it can't, because it's a solid part, it won't machine inside over there. It'll do the maximum that it can. Taking a look at the simulation, it's just going down, machining the most that it can, also finishing up those walls down at the bottom. And it does this for all of these pockets here as well. Now, obviously, these surfaces still have to be finished, but we'll get back to that in a moment. Okay? I also did another HSM operation to work on these surfaces over here. Let's do these surfaces over here. These surfaces on over here, as shown over here. These boundaries over here. Let's do the top view. Working on those areas. I use the option selected faces. Again, using the same, using a ball end mill this time, running my simulation, it'll work on those surfaces. Now, even though this surface was also chosen inside the geometry, it'll only go as far as it can go over here, because this is a solid that's blocking the tool from going further in. So I'll continue on with that operation, and as you can see, it's working on those surfaces, doing the most that it can, as shown over here. Okay, and this is right now being done on HSS. I didn't even get to HSS yet. Okay? But everything done here very simply, very smoothly, not a problem at all. And it's just going to do the most that it can, working up until that area over there. And then it's we'll go over to the next one and do this one over here as well. Obviously, it cannot go underneath over here because the top is blocking it. Okay, let's stop over here. Now I'm going to start my HSS operation. If I were to open up my HSS operation, well, the first thing I'm going to do is, even before I deal with this area, let me deal with this radius over here. I'll open up the operation, and sorry, wrong operation. There we go, HSS. My fault. Okay, we have morph between two boundary curves, where the surface that I want to machine is this surface shown over here, and the top curve, the start curve, is this one over here, and the bottom one, the end curve, is the one at the bottom. Using a typical ball end mill, I just did a toolpath parameter of 0.1 millimeters, and in my sorting, I did the spiral option, going around and around and around all the time on the surface itself with one continuous toolpath. If I were to run my simulation, I'll show my toolpath actually this time. And let me just zoom in to this area over here. You can see the tool goes around. Goes around the part, spiral along that surface over there. Let's stop it over here, do it without the solid verification. Should go a little quicker. And you can see that it's actually working a perfect radius onto that surface over there. Excellent. Next. Now I actually want to start dealing with these areas over here. And this is where the difficult area actually is. If I were to open up the operation, I use the operation option of parallel to curves, where my geometry are these surfaces around over here. Those are the surfaces I want to work on. My drive curve, my edge curve, is these three curves over here, these three chains over here. One over here, one at the bottom over there, and another one over here as well. The tool that I'll be using was a 6 millimeter ball and mill. Now, one thing, obviously, though, I have to do is, since I'm using a regular ball and mill at this point, I always have to make sure that it doesn't go past this area over here still. Okay? So I have to do a gouge check over here. If I were to go into gouge check, we can take a look at gouge 2, and you'll see we have our check surfaces. We're in the check surfaces. Just to be on the safe side, I marked not only this block over here that I don't want to touch, I also marked these surfaces over here as well as these over here. Just to be on the safe side. Does not hurt at all. Now, I just told it to leaving out gouge points. And I also told it stay away from this stock by 0.1 millimeters. Taking a look at the simulation, you can see my toolpath going back and forth on this area over here. But note that when it gets to this point over here, it goes straight across over here because the tool cannot get any closer towards that surface because of this. And I gave it a gouge check. So it knows to stay away from that. So now what do I have to do? I have to finish off the part. To finish off the part, what I did was very simple. I copy-pasted this operation, and actually the geometry is the exact same geometry, taking all of this. But let's take a look further down. If I go into tools, I'm using a Lollipop and mill. And if I go into my area, I have the same gauge check as before. Nothing's changed over here. If I go into my transformation, we have here an option called stock definition. By clicking on stock definition and activating it, what I'm telling it to do is avoid air cuts during using the following stock definition. In other words, it's not going to work on areas where there's no material to be taken off. It sees everything that was left over from the previous operations, and if there are areas that are included on that surface that were already machined, it won't machine those areas. Let's take a quick look at the simulation, and we'll run Solid Verify for a moment. Okay. You can see it's working exactly where I want it to work over there. No problem with that, that's fine. Obviously not touching this surface over here. Obviously you also need the proper tool. So it's doing all the exact areas that have to be machined. Now let's take a look what's going to happen in a moment. What's going to happen is going to continue working. Actually, to do this fact, you can actually see this pretty well in HostCAD. So let me just go over to HostCAD, and we'll just show our toolpath simulation. This here looks fine, but note, there are people sometimes that, even though it's working only in the areas that it really needs to work, over here, which was an undercut, okay, and working on these areas, is skipping this whole area over here and not touching anything over there. You note there's a lot of jumping up, going down as it moves from one area to the next. Sometimes people say, you know what, I prefer going directly across along the part itself instead of jumping up all the time. The way we can deal with that is if we go back into stock definition, I can do what we call expand by 3D offset. In other words, I'm actually making the stock as if it was slightly thicker, say 0.3 millimeters. When I tell it that, then it knows all of a sudden that there's as if there's more material there to be taken off. So what's actually going to happen now, we run our simulation. Let's just finish the calculation. This will take a moment or two. Gives me a good chance to drink a glass of water. Now what it's doing at this point is also, it's first of all figuring out its actual toolpath, also checking for gouge points, or it is also checking for areas that maybe still not have to be machined. That doesn't have to be machined over there according to the stock definition as well. All of this is being calculated now, even as I speak. And the moment the calculation is finished, we should be in another moment or two, we'll run a simulation and we'll take a look of exactly how what actually happens on the toolpath itself. Now remember, before I had a lot of jumping up in a toolpath. This time, because it looks as if there's more material over there, and I'm just waiting for the calculation to be finished. Excuse me. Okay, you'll see that this time the toolpath is going along these areas as well. Okay, because I gave it as if it was an extra thickness over there, so there's still more material to be taken off. And that was done just by going into my area of stock definition and just adding on some excess material as if there was excess material there to be taken off. Okay, I'm ready now for any questions you might have. As I said before also, this recording of this webinar will be available tomorrow at this time on our website, as I showed you before. Okay, I'll just give another minute or two until people will write down their questions. Is that I was probably very, I hope, apparently Looks as if I was very, very clear on my webinar. Okay, I see there are no questions. So again, thank you very much for joining our webinar on HSS, Part 3. And we'll see you on our next webinars. Take care, everyone. Have a nice day. And also enjoy your weekend.